Here I have about 70 data sets from observations of the transient source SAXJA 1808 taken with the NICER mission during its second cycle of observations in 2019. And this transient source, SAXJA 1808, just became visible again in 2022, and I'm going to be conducting a study between the 2022 data and 2019 data. So I need to bring all this 2019 data up to date with the latest software and latest calibrations primarily, so that I know that I'm preparing both sets of data between the 2022 Cycle 5 data and the 2019 Cycle 2 data in the same way. And I'm going to do all of that reprocessing with one simple command right now. Just like that, it's off. I can go do whatever it is that I want to do, and everything is being processed through a default data reduction procedure. This is the new functionality with AutoNICER version 1.2. Let's discuss some more of the details, and I'll do that through some demonstrations here. Anyways, my name is Nick, and I'm an independent researcher in high energy astronomy and or astrophysics, although most of what I'm doing now is mostly in the realm of astronomy, and I'm the creator of AutoNICER, which, for those of you that don't know, is just really a CLI tool that sits on top of an existing installation of HESOFT and will allow you to do a pretty reasonable amount of automation with regard to NICER data retrieval and data reduction. Now, before we go through any of these demonstrations and talk about anything going on, I do need to give the quick disclaimer that this is free and open source software licensed under Apache 2.0. There is no warranty expressed or implied, and you should use this software at your own risk. Whenever you're going through and dealing with pipelining or automation of pipelining, you run the risk of changing up a lot of stuff and potentially doing a lot of damage. You can install AutoNICER just through pip, and with all this code being free and open source, you can find the GitHub page linked in the description down below for you to audit it. I'll encourage you to do so you know exactly what it's doing before you go about using it, because again, if you mess something up, especially with this reprocessing functionality, you run the risk of doing a lot of potential damage. I'll strongly encourage that you have the geomagnetic quantities set up and you're using the latest version of HESOFT. At the time of recording, that is HESOFT version 6.31.1. Okay, so on to the details of AutoNICER. AutoNICER is designed to just do a base data reduction procedure. So that's NICER L2, input, setting up the input directory and clobbering everything out at the end. If you're doing a barycenter correction, it's going to be using the right ascension and declination of the particular observation you're dealing with in question, and it's going to be using the JPLEH 430 ephemeris. Again, all that information can be found in this video here on the first version of AutoNICER. And you still have the ability to retrieve and reduce NICER data using AutoNICER. You can see a quick demonstration of me doing this right now to go ahead and get some of that Cycle 5 SAXJA 1808 data. I'm not going to go over the details of it because, again, you can find out more about that in the version 1 video. Now, there's really three ways of using existing data with AutoNICER, and we're going to start off with the simplest case of just working with a single data set. So here you can see we just have this one data set and we're working in the base of this directory, and that's the way that you're going to want to work with single data sets. Just navigate your way to the base of the directory, which is just the observation ID. You should see the auxil, log, and xti directories, populated with all the data in there, and this is where you want to be working from. So the first thing that we can do with AutoNICER is check the state of our calibrations. If you have a lot of data around, you might not be knowing what calibrations were used to process a data set, and so you can do this or check the calibrations with a simple run right here of AutoNICER with this check cal option. We can hit enter. And you can see it tells us whether or not we are up to date with the latest calibrations. It's reaching out to the HESARC and grabbing the latest version of calibrations for NICER and just kind of comparing the two of them together. And if they don't match up, well, then it's going to tell you in big red letters just like this, or it'll say it in green letters if you are up to date. This will check barycenter corrected MPU7 cleaned event files or non-barycenter corrected MPU7 cleaned event files. So it's just basically looking for any cleaned event files in your directory. Now, let's say that we're not up to date with the latest calibrations. We can go ahead and reprocess this data really simply and really easily using AutoNICER with this reprocess bit of functionality, but I'm not going to run that just yet. because we can combine the two of these options right here, check cal and reprocess, where AutoNICER will check the calibrations of a data set. If the data set is not up to date with the latest calibrations, it will then go ahead and reprocess everything using NICER L2. Now, AutoNICER will auto-detect if there is a barycenter corrected MPU7 cleaned event file if you're using the naming convention I do of replacing the NI prefix at the beginning of an MPU7 cleaned event file name with BC. So it'd be BC followed by the observation ID and then MPU7 CL EVT. It will also auto-detect whether or not there is compression of the UFA files, and it will auto-compress all of your UFA files as well, provided that it detects that compression is there. But let's say you don't have a barycenter corrected event file, or you're not following my naming convention, or let's say that you don't have stuff compressed, but you would want it compressed, or you'd want a barycenter correction. Well, there's two other options that we can add in here. We can run AutoNICER with check cal and reprocess, and then we can add in this BC option as well as this compress option, and this will force out a barycenter correction as well as compression into gun zips of, at the very least, the UFA files. But if you elect for a barycenter correction, it will also compress the non-barycenter corrected MPU7 cleaned event file. Again, if you don't want to check the calibrations at all, you can go ahead and just run reprocess, and it will forcibly reprocess everything and you can also add in BC and compress, but BC and compress can't be used with check cal. Check cal is really only designed to work on its own or with reprocess. For this, you can see we're going to be switching over to a different bunch of data here, and you can see that all of this data here is for Pulsar J0437 minus 4715, and I have a lot of data sets here, to say the least. Now, again, I'm regularly working with new data sets, and I'd like everything to be up to date with the latest calibrations using the latest software. And so we can run AutoNICER with check cal and then -I, or again, you could put enlist for the whole thing. And then we're going to put a star here to select all of the observational data that is sitting in this current directory. And we're working from this base directory right here. Hit enter, and it is going to run through everything. And you can see it's taking a while. This is running in real time, and it is checking the calibrations. Again, big green letters if you're up to date with the latest calibrations, red letters if you're not, and it's running through all of that and letting you know that right away. Now, say I want to reprocess that, and I actually recorded this clip from before I realized I didn't record the check cal option right here, is I'm running that with reprocess, and then -I with star, and it's going to be reprocessing everything. Now, this is a lot of data, and AutoNICER is designed to go through and reprocess this. But again, when you're going through this much data, you run the risk of potentially clobbering something that you might have needed. So just really make sure you know exactly what you're doing when you're using this I option, or this enlist option. I would not recommend just using a star like I used right here. Maybe go for a more refined or specific input right here, such as, let's say you want all the cycle 4 data, you could go with like 4 star, for example. Now, the last thing with this enlist option that it actually allows for is AutoNICER has a built-in logging function. So let's say you have a lot of data sets all over the place. You're not just working from a single standalone directory. What you could do is you can create a simple 1-column CSV file with the column name input, capital I, the rest is all lowercase, and then just put the full path to the base of the OBS-ID dataset. You could go ahead and go all the way to an MPU7 cleaned event file if you want to, but that's not required. You just need to go up to the main base of that dataset, and you can just feed in that CSV file. It doesn't need to be denoted as CSV or anything. It could be like a .list or .text or whatever, but 1 column, and then just the full path to that base OBS-ID dataset. And so that's the functionality to come with AutoNICER version 1.2. Again, at the present time of recording this, I'm on version 1.2.4. Bear in mind, I'm going through a lot of data, and with doing that, I don't really care too much about the specifics of data reduction, unless I'm looking at something like Vela, where I have to do some really, really weird data reduction to take into account some of the weird things we've observed with Vela data sets, amongst others, at least with regard to the South Atlantic anomaly. In that case, I'm doing a non-standard or non-default data reduction procedure. But for me, the base level data reduction procedure is good enough for me. And AutoNICER is something that allows me to do this type of stuff really, really easily. That's what it's designed for. It's designed for you to just set it up and forget it. A lot of times before I go to bed, I just say, hey, what data do I want to, go through and double check on, or what data do I want to go ahead and prepare? And I just pick one of my drives and I just start going. I'll encourage you to check out the wiki if you'd rather see some of this stuff in text media rather than video. That will also be linked in the description down below. And if there's any additions or changes or anything you want to make to it, again, go right ahead and, submit a pull request. Let me know, run the tests. Everything's using Poetry, so you can just install stuff with Poetry and then, run the tests just with PyTest. Now, at the end of the last video I made about AutoNICER with version 1.0, I'd mentioned that I wanted to create standard product pipelines, and luckily the NICER team has already done that. I've made videos on those NICER L3 pipelines, and I'll add in a little bit of functionality for that, but bear in mind that a lot of the development that goes to AutoNICER is really dependent on the research work that I'm doing, and so unless I really have a big need to add stuff to it, I'm not as inclined or as motivated to work on it as much. If you have any questions, comments, or concerns, don't hesitate to let me know. Here, again, also don't hesitate to submit issues. If you make any changes or additions or whatever, submit a pull request. Those of you that have found, other interesting ways of reaching out to me, you can go ahead and do so through that. Again, be respectful. If you're not, I'm probably just going to ignore you. But anyways, thank you very much for watching. Happy 2023 NICER analysts, and hopefully we got some really cool neutron star science and discoveries coming in the new year. Thank you again for watching, and I'll hope to see you again next time.